Hi everyone, this is Kruti Jai Pancholi, Assistant Professor in LJ Institute of Engineering and Technology in Department of Electronics and Communication. This video is about subject Microwave Engineering. Based on this, example is a 50 ohm transmission line is terminated to load of 25 plus 50J. The length of the transmission line is 3.3 lambda. Find the reflection coefficient VSWR, input impedance, input admittance. So very first we need to write down the data for this. So here 50 ohm transmission line, it's a characteristics impedance. So I write over here Z0 is the 50 ohm. Fine. The load impedance is 25 plus 50J. So if I'll draw the diagram over here for this, then you can keep in mind it is the generating end, then the load impedance we have, so it is my ZL, and what is the value of ZL? It is 25 plus 50J. What is the value of the Z0? It is the 50 ohm. So Z0 equal to 50. And what is this? This is the length of the transmission line from source to load. It is how much? 3.3 lambda. So for this we need to find out reflection coefficient. What is reflection coefficient? It is rho. It is VSWR. It is input impedance. From where we can find out input impedance? From this point we can find out the input impedance. Okay. So it is the input impedance Zin, and we need to find out the input admittance, that is the Yin. So now first of all we need to plot the ZNL value. Okay, what I want to find out in my first case, reflection coefficient from the graphical method. Okay, so ZL is equal to 25 plus 50J. So ZNL is equal to ZL upon Z0. What is ZL? It is 25 plus 50J. So 25 plus 50J upon 50 equal to 0.5 plus 1J. What is 0.5? It's a small r, and it is the resistive portion. It's a reactive portion. Reactive portion is 1. So now the first part, for this, very first I need to plot the ZNL value, normalized impedance. This is the point, that is the 0.5. So now you can see that this is my 0.5. Now another is plus 1J. So reactive portion 1. So now you can see over here that from the graph we can have the value of the ZNL. That is over here. Fine. So this is my normalized value of this normal impedance. Now what I need to do, that I need to draw the one line from the constant point 1. This is my what? It's my the resistance value, that is equal to 1. So what should I do? That I have to take the scale from the point resistive R equal to 1. You need to take the R is equal to 1. Unit circle. So from the point R equal to 1 to this normalized impedance, I need to draw the one line. Now taking the radius this, you have to draw the circle. Radius is this. From the point 1 to the ZNL, that is my radius. So that radius I need to take, and I have to draw the circle. Now that circle, Okay, that circle will cut at the some point onto this reference line. So here you can see that, okay, this circle will cut at this point. Okay, so this point, it is referred to as a constant VSWR circle. Constant VSWR circle. And this VSWR circle means this point, when you will read it onto the Smith chart, it would be 4.2. So this 4.2 is my VSWR value. Okay, so now again I am repeating, okay, that what I did, normalized impedance, find it out, fine. Now this is the normalized impedance. Here the line is drawn, okay, so you can see it, fine. So this is the line, okay, it is my 0.5 that I have drawn over here. Fine, this is the 0.5 plus 1j. This is 1j. This point, what I need to do? Draw the line from this point 1. Okay, it's a constant resistance. R equal to 1 we will take. Fine, take the radius of this 1 to ZNL. Draw the circle and the circle will cut at some point. Okay, that's nothing but VSWR. So it gives me the VSWR value. So in the theory we have studied also that VSWR is equal to 1 plus rho upon 1 minus rho. So it is VSWR value is 4.2 is equal to 1 plus rho upon 1 minus rho. So my modulus of rho is equal to 0.615. So now this value that gives me the modulus value, when it gives me the magnitude value. But I do not have this reflection coefficient that consists of the magnitude and the angle. So now how do I find out the value of the angle? So to find out the value of the angle, what should I do? That I am having this point, okay, earlier you have seen that, okay, I am having my Z and L portion, okay, I am having the Z and L portion. So what I need to do, that this is my the point, okay. Now what I need to do, I will extend this line, okay, towards this, and over here you can see that here it is written, it's an angle of reflection. So what you will do, you will refer this particular portion for finding out the angle. So extending the line from this Z and L to the angle of the reflection, it is around the 82 degree. So this way I can find it out, the angle of the reflection. Another way, from the graph we can also find it out, the value of the rho. How? That I can have the distance from this point number 1, mean R is equal to 1 to this ZNL point, okay. So this is nothing but my DL value, and the another point that is from this 1 to this point, okay, to this angle of reflection point, that is L. So using the scale, you need to measure the value of the length and put that length value over here. So your rho, that is a reflection coefficient, that's a DL upon L, and having the angle, okay, that you can find it out using this method. So you can say that the angle of the reflection as well as the reflection coefficient value, that I can find it out from the graph. Next is, I want to find out the input impedance value. This is the diagram. Generator, load, this distance is 3.3 lambda. it is the point at which I can find the value of the my input impedance. So this is the point at which I can find out the input impedance value. Now, what I discuss for that, I said that while you are moving the one particular the Smith chart, okay, one round of the Smith chart, it cover the lambda by 2 value. Fine. So now the lambda by 2 value, if I will go, okay, over here it is 3.3 lambda. Okay, so here the one round if you will move, then it will cover only lambda by 2 for the one moving. Okay, so here the 3 lambda, 3.3, but the 3 lambda, okay. So it is the how many circles? So I need to move the 6 circles, okay, for covering the 3 lambda value. Okay, so what I will do that I will move the 3 circles. Okay, so while I am moving the 3 circles, what I should have? I have this value of the lambda at this point, okay, and I need to extend this line towards here. Here you can see that the wavelength towards the generator. So this particular value that you can have, that you have to read it. Okay, so this value I have, it is the my 0.13 lambda. Fine. So by moving the 6 times circle, okay, 6 times circles, okay, then I can have this value. Fine. Now after moving the circle 6 times, which value that is remaining again? It is the 3 lambda. Just a minute. It is the 3 lambda. Okay, 3 lambda first of all, and another is the 0.3 lambda. Fine. So what I should do, that by moving the 6 times circle, the value is 0.13 lambda. But how much is remaining? Still 0.3 lambda. So what I will do? I will add that 0.3 lambda in this value. So now my value is 0.43 lambda. So now what I should do, that you can see over here, by extending that value, it is my 0.13. Now how much value I need to add towards the generator? Okay, that is a 0.3 lambda. Okay, so 0.3 lambda, while you will see onto this external line, it would be somewhere over here. Fine. So this is my 0.43 lambda. So this 0.43 lambda. Okay, this 0.43 lambda. So now what I should do? I need to draw the one line from the center to this 0.43 lambda, and wherever it cuts this VSWR circle, that is my Z in value. So Z in is equal to 0.24 minus J.4. Okay, so this is the Z in the input impedance. But you know that the value which you found onto the Smith chart, that's a normalized value. But while I want the exact value, I should convert that into my original value. Fine. So it is what? So I need to find out the value. That's a normal, that is the original value. So my Z in is what? It's not this 0.24 minus 0.4J, but it is what? It is the 50. Multiply by 50. While you are normalizing, divide by 100. Finding out the actual value, multiply by 50. So it's a 12 minus 20J. So this point is 0.24 minus J.4. Okay, finding out the exact value, multiply by 50. So now the last portion of the example, it is the admittance value. So what admittance is what? So it's just the opposite of the Z in. So this is the Z in, Draw the exact opposite line onto this part, this portion that gives you the value of the Y in. So read this value according to the concept of the resistance and the reactance. You will find the value of the admittance. So it is about the example related to um, the Smith chart. So please solve it in your book and get the answers about all this. So always the practice makes man perfect. So practicing onto the Smith chart, okay, that can reduce our task of the calculation. So thank you very much, everyone.